Hello guys, welcome back to our programming series, Programming with C. And in this video, we'll try a few examples with the variables and data types. Let's dive in right away. Okay, so let's create a new file for this video, and that is going to be variables.c. Okay, now the default structure of C code, hash include stdio int main, the gateway to our program, and then the curly braces, and all with a return 0. Terminate. Sorry. All right. So we have our default structure set. Let's go. So in creating a variable, as I said in the previous video, you have to give it a data type, which is an identifier. It defines the type of values that can be assigned to the variable. So if you want to assign numbers, whole numbers to the variable, you use the int keyword. If you want to assign values or variables, if you want to assign float values or decimal values, then you use the float or double, but usually the float will work with the float quite often. And if you want to assign letters, as in A, B, C, D, single characters, to your variable, use the character variable. But using a character variable is slightly complicated, but we'll treat that in this video, so you don't have to worry. So let's name our first variable. In naming a variable, we know a variable name can contain numbers, alphabet, be it uppercase or lowercase, and the underscore. So let me give this a number. And looking at the name, it has is valid according to the naming rules of variables. This is a valid name. So let me try something new here. Yeah, decimal values. I'll separate it with an underscore. So this turns out to be a valid name for a variable. It has an underscore here, which in the rule of naming variables is valid. Okay, now in this case I'll use an uppercase and a lowercase, so character. And C doesn't mind where or which part of the name of your variable you use the uppercase. It could be in the middle, it could be at the latter part, or 3 characters away from the first. Anywhere in your in the naming of your variable, you can use any case. So most programmers use the camel case because it's in C. Capital C or uppercase C is different from lowercase c. Okay, uppercase n is different from lowercase n, so it makes naming variables much more easy and gives you the chance to have variances of variable, because you can have number all in lowercase, you could have int number again, and these two are different variables. This starts with the uppercase, this starts with the lowercase. You could create another one, int number. This is also a different variable. Alright, so it doesn't matter where or when you use the uppercase, so far as it's within the name or it's in the name, it's valid. The second rule says don't start with a number. Don't start the name of a variable with a number. It's invalid. So I put 2 here, it makes this invalid. See, it's underlined with an error, which makes it invalid. But you can end it with a number and it won't show anything. You can put it in the middle and have several numbers within the name of a variable, and it's okay. But your variable shouldn't start with a number. It's wrong, it's not good, it's not valid. You don't have to use special characters like the addition sign, the manual sign in the name of your variable. It also makes it invalid because addition sign, as you know, is to add 2 or more values or operands, minus to subtract, the equal to assign or equate something. So these special characters are not valid, but you can use either the ampersand or the asterisks. They are used as pointers to point at the memory location or the memory address of variables. Apart from these two, and probably a few other characters, most characters are not valid to use in the name of a variable. For instance, plus here show an error because it's not valid. Okay, you just don't do this when you're naming a variable. Just go straight for it. Name it something simple, something you can relate to make it easier for you and probably your colleague programmers. Okay, so characters, I'll create another character variable. By this time, let me use small just for us to get a difference. This time I bring in the square brackets and I put in numbers between them. Okay, so in this case, this here, this is also a character variable, but it's an array. So an array is a list or a sequential series of variables of the same kind. Okay, but since character here can accept only one character or only one value, that could be A, D, E, F, G, or whatever value, but in a single quote, this gives it an exception to get more than one, but you assign one to each memory space. So this character here has 30 memory spaces, more or less like having 30 boxes arranged in a series, and they are all indexed with an ID. So since they are 30, so 0, 1, 2, 3 to 30, so the numbers are their IDs. So if you want to access what is in box 1, you access it by characters in the square bracket 1. That is the index or the ID of that box. If you want to access something in box 15, characters square brackets 15. That's what you get there. You get the value of what is in that variable. Alright, so let's assign values to each of them. So since number is an integer, which is whole numbers, let me make this 54. Alright, and float for decimal values, let me give this 23.589. terminate. And character can only take one value, so let me give it a D. So, and uses only a single quote. You should know that. D. Right, let me terminate this too. Let me reduce this to 5 to make it easier for us. Alright, now with this I will assign 5 values to this character here. What are the small letter? So the listing of the variables in an array in most programming languages, especially C, starts with 0. Okay, so 0, 1, 2, 3, 4. That gives you 5 values. Alright. Okay. Character 0. Let me spell a name. So A. Let me duplicate this. Shift Alt arrow keys down. I think this is 5. Alright. That A. Make this 1. R. O. N. Okay, so the name may run 2, 3, 4. Alright. Realize that we didn't have character array 5 because 5 is the size of the variable, the array variable, but when counting it starts from 0. So 0, 1, 2, 3, 4, which is 5. Alright, so now let's print the values of each of them. Printf. The first one is a number, so %d and then the variable. So let me duplicate this first. So how many variables do we have here? 1, 2, 3, 4. We have 4, but this is 5, so we'll print them one by one, which will be 9. So I have to get 9 of these. I'm not sure I would like to type this 9 times. Okay, so now number. The next one is a float, so F. Decimal values. And then this one is a character, so C. Okay, and capital character. Alright, the rest are also C. Make this C, and then by this time I bring the index, so 0. Let me repeat this and just change the index. One, 2, 3, 4. Let me bring a new line to this, each of them, so that we see what is printed on each line. Let me save this and run it. Okay, 54, that's the first value here. 23.589. D, single character. A arrow N from the array. Okay, well, that these are printed as different values. You can also keep them in one line. Comment this here, make this S to make it a string, which means all the words, the variables in it will be seen as one whole word or a sentence if it is a sentence you have put in that character variable. So let me run it again. Okay, found some errors here, some funny values. Okay, fine. So we now have created variables, assigned values to them, and have printed them. And to work with the characters, especially the one in this array, let's say you're having a longer name or you want to enter a sentence into the character value variable, you wouldn't want to do this in a sentence, as in type in or enter every single character letter by letter into the array. It's going to be a lot of headaches. Like, why will you programming still have this problem? Because programming is supposed to make stuff easier, and you are struggling to make your own programming experience easier. Alright, so there is this header file. This as we included the stdio for the standard input and output functions. Also have this for manipulating strings .h. So it gives you some default functions or inbuilt functions in C to manipulate strings. So instead of doing this, you can do all this in just one line. Alright, so let me try this again. So this time you call in on the function strcpy, that is string copy. Then first argument is the name of the variable. So the variable characters. The next argument is what you want to put in the character. Remember, the size of your character is 5. So whatever you put here shouldn't be more than 5. Else it will show an error, or it will truncate the values to the 5th character. Alright, so let me use a different name, like shorter one. Okay, I think James is 5 characters. Alright. At least when we print, we should expect James fully printed without any funny symbols. Let me rerun this. Okay, so James has been printed successfully. James here is printed successfully. Alright, let me clear this. If you want to work with strings, so you increase the size. If you want to write something longer, then you could make this 50 if you want to write something longer. So James is the name of a guy I know. Okay. When you need to print it, yeah, so James is the name of a guy I know. So the code is working perfectly, and I go to assign strings to a variable. As easy as that. Okay, so now let's put our variables into some printed statements, not just print them as in here, but print them in a statement. Let's see, we have number 54, float or decimal value 23, and D, and James, the name of the guy I know. Alright, so let me see if I can create a statement from this. Printf. So yeah, first percentages, that is for string, and I want James is a name of a guy I know to be printed at this position of the statement I want to print. And I put a full stop there or space, and then he is percentage D. I want this to be his age, presentation of his age. So this, there's a placeholder to be replaced with this. when printed is years old. He has an average rating on eBay. That's sorry. That's so this on this will be 23.589 average rating on eBay. So percentage float should be that, and then D and is grade percentage C on the market or something. Alright, so this is statement that makes sense. Let's say you collected this data from the user. I want to print something to something the user can understand or something meaningful to the user. This is how it goes. So now these are just place values. Okay, the percentages here, though they specify the format of the value to be printed out, they also use as placeholder. So wherever this is supposed to be placed with something, and in the order they have been placed here, that's the same order you enter the variables here. So the first one is a string, and we want characters to be printed there. So we write the name of the variable there, characters, that's the small c, and then the next one, decimal year old. So this should be age, which is number. So number, and then we have a float for the average rating, and that's decimal value, right? So decimal values. And then C, character for the aggregate, right? Sorry, the grade, right? The grade and character. Alright. Always remember to separate every argument with a comma. Okay. We have it here. So this should be replaced with this characters, right? And this will be replaced with this. So the order for whenever you change any order or format here, or the format or order here, it will affect what will be printed here. It might corrupt it or show an error. So now let's run this, and we are expecting James is the name of a guy I know. He is 54 years old and has 23.58 average rating on eBay and is grade D on the market. So let's see if that's what we are going to get. Yes, I guess that's what we got. So James is the name of a guy I know. He's 54 years old. He has a 23.59 average rating on eBay and is grade D on the market. Wonderful. Okay, so this also tells us that the format specifier is also a placeholder. So it shows, or it can be put in place, or a particular place you want your variable or value to be printed. Let's say we had changed the format or the order of this. Let me put this here. Let's see what happens. Let me also bring this here. Let's see how it affects the program. Realize it didn't print anything because the order has been altered. The order has been changed. which will cause an error, sometimes won't display, or sometimes will show a corrupted value, which is what we don't want. So whenever using the placeholders or the format specifiers, please make sure that you arrange them in the order of which you want them to be. It's very important because these are matching values. So if you mismatch them, you mess up your results. So I guess this is the end of this video. In the next video we'll be trying secondary data types, that's the union and the structure, and probably the pointers data type. So catch you in the next video.